Hey y'all. So we're still looking at complex inheritance patterns here. This time we're looking at question number 6. We've already been over incomplete dominance. We've been over codominance. Those were both questions 1 and 3. Okay. But now we're going to go over number 6. Number 6 says a father is heterozygous for his type B blood and the mother has type O blood. What are the different possible blood types for their offspring and the probability of each? Well, let's think back to what type of inheritance pattern blood type is. It's codominant. Whenever you receive an allele for blood type, you express that allele. So if I've got two different alleles, then on my red blood cells, my blood type will be a result of having both those alleles. So if I receive just A's, I'm going to have blood type A. If I receive just B's, I'm going to have blood type B. If I receive A and B, I will have blood type AB. And we'll also look at blood type O. But the first thing I want to do is go over the possible blood types. So you can have type A, you can have type B, you can have type AB, and I had to resist the urge to write type C. But then you can have type O. Okay? So those are your possible phenotypes, what you would express, what your cells would express. What are the possible genotypes for each phenotype? So for type A, you can either have AA or AI. Now I want to be clear with something with regards to this I. You may see it represented as AI or AO. Okay? The I just represents the O allele. In some instances, for whatever reason, I cannot answer the question here, but for whatever reason, it is sometimes referred to as I. Okay? So, type B, the possibilities are BB or BI. For AB, you can only have the A and B alleles, BAB. Or for O, you can simply have the O alleles, II. So let's find out what the probabilities are if we cross a heterozygous type B blood type with a mother who has type O. All right, so what's the father look like? It says a father is heterozygous for his type B blood. So if we look over at blood types, type B is right here, and it gives us two options, BB or BI. Which one do you think is the heterozygote? Hopefully you said BI because BI is two different letters, B and I. If it would have said the father is homozygous for his type B blood type, homo means the same, right? The only option would be BB. But he's heterozygous, so his blood type is BI. All right. It says the mother has type O blood. She only has one option as far as genotype, and it's II. So let's cross those up. Your possibilities are BI, II, BI, and II. What are the probabilities? For type B and type O, because we know the probability for having A and AB are 0. They're not expressed anywhere in the offspring. So remember, type B can either be BI or BB. O can only be II. In this case, how many of the offspring, what chance of the offspring is going to be BB or type B? 2 out of 4. 50%. What about type O? That's right, 50% or 2 out of 4. So we just finished talking about another type of codominance. Now, this version of codominance is also considered multiple alleles. The reason this inheritance pattern is codominance and multiple alleles is because you have more than just 2 alleles. You have I, B, and A, and all of them can be represented if they are found in the genotype. So this is why it's codominant, because if I have 2 letters, both are represented in the genotype, and there's more than just 2 alleles, A, B, and I. All right, that's it for codominance with blood types and multiple alleles. Hope that was helpful.